Hi everybody, today we are going to talk about binomial expansion and the binomial theorem. Okay, so before we talk about the formula for binomial expansions, I want to talk about a really crucial element of that, which is Pascal's triangle. So there is a definite pattern to the numbers in each row. So essentially how you get the numbers in each progressive row is by adding up the two numbers above it. So 1 plus 1 is 2, and you could even think of it as like 1 plus 0. So all of the ends are going to be 1s going all the way down on the left and the right. But then if you look here, 1 plus 2 is 3, 1 plus 2 is 3, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, so on and so forth. So you should be able to continue on this pattern to find each successive row. And one really important thing to note is that the tip of this pyramid right here is technically row 0. So row 1 starts in what looks to be the second row, but this is actually what we call row 1. Now, there is a formula to do binomial expansion. So any binomial raised to a certain power, we can create this formula by using the numbers from Pascal's triangle, and then we're going to follow a specific pattern using x and y, where essentially the degree of x decreases for each successive term from n, whatever that highest power is, down to 0, so your last term will actually have no x. And then the degree of y increases from 0 to n. So they kind of go in opposite directions, but this means that your first term will have no y. So let's see if we can fill out a few rows of our formula for binomial expansion. So for row 1, the two numbers from Pascal's triangle are 1 and 1. And then we start with x to the power of 1, and then x to the power of 0, and then y to the power of 0, y to the power of 1. So this one is pretty obvious because it's just x plus y to the power of 1, so 1x plus 1y. Now for row 2, the numbers from Pascal's triangle are 1, 2, 1. Then we start with x, so we have x squared, x, and then x to the power of 0. And then here we'd have y to the power of 0, y squared. So you can see that the degrees for x are getting smaller and the degrees for y are getting bigger. For row 3, our coefficients are 1, 3, 3, 1, and here we'd have x cubed, x squared, x, no x, and we can even work backwards. Some people prefer to do that. Y cubed, y squared, y, no y, and then we just put some plus signs in between. Let's try 2 more rows together. So our coefficients are 1, 4, 6, 4, 1. So x to the 4th, x cubed, x squared, x, and then y to the 4th, y cubed, y squared, there we go, y, and then no y. And our last one, the coefficients from Pascal's triangle are 1, 5, 10, 10, 5, 1, and then we have x to the 5th, x to the 4th, x cubed, x squared, x, and then y to the 5th, y to the 4th, y cubed, y squared, y, and then we just put plus signs in between. So you have it. So once you have your formula, you're essentially going to go in and plug in whatever you have for x, you plug it in for all of your x's, and whatever you have for y, you plug it in for all your y's, being careful to do this with parentheses, and then you just simplify. So let's try a really basic one. Here we have x plus 1 cubed. So our little formula for this is x cubed plus 3x squared y plus 3xy squared plus y cubed, and I can see that our x value is just x and our y value is 1. So now I'm going to substitute. So x cubed, and I know that it looks silly to substitute x with x, but this is just to be really thorough and to kind of establish good habits for harder problems. And then you just go through and simplify. X cubed plus 3x squared plus 3x plus 1. All right, go ahead and pause the video and give this problem a try. Okay, So here's our formula, and here you can see I substituted x with x and y with 2. So now here you have to be a little bit careful when you're simplifying. Here we have 2 squared, and then you have to multiply it by 6. So it becomes 24x squared. Here you have 2 cubed times 4, and here you have 2 to the 4th. So you do need to make sure you simplify each individual thing that you're substituting, and still remember to multiply it to the coefficient. All right, now we're going to try a couple problems that have x or y values that have maybe a coefficient and a variable. So for this first one, our x value you can see is 2x, and our y value is -3. So we're going to plug this into our formula for row 4. So we have 1 times our x value to the 4th plus 4 times our x value cubed times our y value, which is -3, plus 6 times our x value squared times our y value squared, plus 4 times our x value times our y value cubed. Let me slide out just a little bit, and then we have plus our y value to the 4th times 1. So you can see here that we do need to do quite a bit of simplifying, because here we have 2 to the power 4 and x to the power 4. Be careful that you are doing the entire term. Here we have 4 times 2 cubed times -3. Here we have 6 times 2 squared times -3 squared, so on and so forth. So when you simplify this, you should end up with 16x to the 4th, minus, because of that -3, so minus 96x cubed plus 216x squared minus 216x plus 81. So just be careful that when you're substituting, especially when you have something like 2x, if you do it with parentheses, then you won't forget that you need to cube the 2 and the x, for example. So just be careful there. Now let's try this next one. So we have another one. We're using our row 4 rule. So we have our x term to the power of 4 plus 4 times our x term to the power of 3 times our y term plus 6 times our x term squared times our y term squared plus 4 times our x term times our y term cubed plus our y term to the 4th power. So here, once again, you need to be very careful that, for example, here we are squaring -2 and y. Here we are cubing -2 and y. So make sure we're simplifying fully, and we should get x to the 4th minus 8x cubed y plus 24x squared y squared minus 32x y cubed plus 16 y to the 4th. So that is our expansion. All right, go ahead and pause the video and give this problem a try. All right, so here you can see the formula that I used. I substituted x with 2x and y with -y, and then you should get this when you simplify. All right, I would also like you to pause the video and give this problem a try. I know that it's slightly different because our x value is x squared, but you still follow the same exact process that we just did. So see if you can figure this one out on your own. All right, let's check your answer. So like I said, if your x value has an exponent, it doesn't matter. You still plug it in the same way, and then you just simplify by multiplying the exponents. So same process. It doesn't matter what this value or this value are. Just plug them into your formula, and you should be good to go. Now, I want to talk about something really important. It's called the Binomial Theorem. So this Binomial Theorem allows you to find a specific term within your expansion of a binomial. So this is the formula. It's n choose r times x to the power of n minus r times y to the power of r. So first, let's talk about what this n choose r is. This is a formula for a combination that we'll talk about later on in this chapter. But essentially, the way you find this value is just n factorial over n minus r factorial times r factorial. And then whatever your x value is, you raise it to the power of n minus r. And whatever your y value is, you raise it to the power of r. So one thing I would like to point out is that this n is the row that you're working with, or whatever degree you're raising your binomial to. And r is 1 less than the relative position of the term. Now the reason why that's happening is r is essentially the degree of your y value. Your first term, the degree is 0. You don't have a y value. For your second term, you have y to the power of 1. So you can see that even though it's a second term, this r value is 1 lower. So for example, if you were trying to find the 7th term of your expansion, you would use r equals 6. So that's always going to go 1 down. But from there, you're just going to plug it into this formula, and you can find this by plugging into this formula. And that allows you, once again, to find a specific term within your binomial expansion. All right, so let's try this problem together. For problems like this, I always like to list out what x is. So x is a, and also y. I can see that our y value is 2b. And I also like to list out n and r. So n is going to be 8, because that's this value. Oops. And then our r value, remember, is 1 less than the relative position. This says find the 6th term, so I'm going to use r equals 5. And this I'm just going to plug in to this formula. So let's start by finding that n choose r. So we have n factorial, which is 8 factorial, over n minus r factorial times r factorial. So remember, in simplifying factorials, like if I do 8 factorial over 5 factorial, everything 5 down has been simplified. So I have 8 times 6 times 7. This is 3 factorial, so I have 3 times 2 times 1, and I can simplify here, and then here, and then we have 4 times 2 times 7, which should be 56. So that's that coefficient out front. And now I substitute x with a, and then I do to the power of n minus r, which will be 3. And I substitute y with 2b. That's our y value. And then that's to the power of r, which is 5. Now here we do need to simplify. Oops, sorry, that disappeared. There we go. Here we need to do 2 to the power of 5 and b to the power of 5. So here 2 to the power of 5 is 32, and then I'm going to need to multiply that to 56, and we should end up with 1,792. And then we have a cubed, and then b to the power of 5. And one thing to note, if you add up the degrees of your two variables, they should always equal whatever that n value is. And 3 plus 5 is 8. So that is the 6th term of that binomial expansion. So instead of having to find the entire formula, we can just use this binomial theorem, and we can find that specific term. Okay, let's try one more together. So it's worded a little bit differently, but we're going to use the same formula. So find the coefficient of a to the 6th, b to the 5th in the expansion of this. So I can see that in the binomial, our x value is 3a, and our y value is negative 2b. I can see that n is 11, which I can see here, or I can add up these two, and it's equal to 11. And then remember, this is our r value. It's y to the power of r. So this is our r value. The r value is 5. So now I'm just going to plug it into the formula. Let's start by finding that n choose r. So we have 11 factorial over 11 minus 5 factorial times 5 factorial. And if you simplify that, it becomes 462. So then we have 462 times x, which is our 3a, to the power of n minus r, times y, which is negative 2b, to the power of r, which is 5. So here, be careful. We do need to make sure that we are raising 3 to the power of 6, a to the power of 6, negative 2 to the power 5, and b to the power 5, and then multiplying those coefficients by 462. So we end up with negative 10,777,536. Then we have a to the 6th, b to the 5th. And technically they did just ask for the coefficient of our term, so it's going to be this right here. Okay, go ahead and pause the video and give these last two a try. Okay, so go ahead and check your work. Once again, we're just using this formula for each one. I recommend listing out your n value, your r value, your x value, and your y value, but just plugging it into the formula. So that is all for today. Thank you so much for watching.